Okay, so the next law we're going to look at is probably one of Newton's most famous laws, which is Newton 2. And this is at the heart of a number of scientific calculations. One of the most famous equals mc squared is built on force equals mass times acceleration. So what this law does is it defines the relationship between force, mass, and acceleration, as I've just said. So so it seems quite reasonable to accept that for a bigger body of a particular mass, the bigger the force is needed to make it to accelerate, which makes sense. If I've got a great big ball that weighs a lot more, it's going to take more force for me to push it, right? And make more force to accelerate it. And the larger the mass, the larger the force will need to create a particular acceleration. Okay, so what we're saying is force is equal to mass times acceleration. And therefore, we could say, well, this is our constant. So force is proportional to acceleration. Or as even we've said before, so force is proportional to dv by dt. And then we start to understand the relationship here. And we can understand exactly if this was an m here again, we can see that actually this force is quite important to understand the motion of any body. We won't go into circular motion, but understanding how satellites travel around the Earth, understanding all sorts of different calculations, even as I said, the equals mc squared, force equals mass times acceleration is at the heart of it. So it's quite a simple one. So we're going to just explain it with some examples. So here we go. So let's just actually, if we think about Newton, so I've said that force equals mass times acceleration before we start the example. So if we think of mass as a kilogram, and we think of acceleration, well, we've done this last week, our acceleration is meters per second squared. Well, all of a sudden we've got our units for force, which we call newtons in this country. Some countries don't, but we call them newtons. And we can also see that mass here is related to the way in which the force moves. So the unit of force is defined as the amount of force that gives 1 kilogram an acceleration of 1 meters per second squared. Okay, so let's think of this example. So our example A is a force of 12 newtons acts on a particle which weighs 5 kilograms, and it says work out what its acceleration is. Okay, so we use force equals mass times acceleration. And what we got here, we have our force, which is 12, equals our mass, which is 5 times by a. Therefore, acceleration must equal 12 divided by 5, which equals 2.4 meters per second squared. Okay, quite simple, right? Let's do something a little bit more difficult. So the next question says, the diagram shows the forces that act on a particle of mass 5 kilograms, causing it to move vertically downward with an acceleration of a meters per second. Find the values of P and the values of A. Okay, so we might need to use some of our Newton 1 here. So we draw our particle, and we see that 6 newtons going down there, and it has 3 newtons going up like this. This isn't to scale. We have 1, which is P newtons, and we have 1, which is 7 newtons. Okay, so first of all, it asks us to find what P is. So the question says that the ball is moving vertically downward. So that insinuates there's no horizontal motion. So if we were to resolve that, we would say that P minus 7 must equal 0. Therefore, P equals 7. Okay, nice and easy. Okay, so we're not bothered about these. These have gone. We just want to look at our vertical motion. So what we want, therefore, if we want to resolve downwards, we can see that, well, actually our downwards motion, maybe we call this positive down, would be 6 minus 3. So then our resultant would be 3 in that direction. Okay, so that means that we have our mass, which is 5 kilograms, we've said. So can we work our acceleration, which is A equals, or we'll do it, F equals ma, which equals F, which is 3, equals m, which is 5, equals multiplied by a. Therefore, A equals 3 divided by 5, and we could probably leave it at that. We can say that A equals 3 over 5 meters per second squared. Okay, fairly straightforward once you've got past that slightly tricky bit at the beginning. So, okay, so what about if we now make it even more difficult? So we can say C. So a force F acts on a particle of mass 3 kilograms, okay? So we've got two parts of the answers. If the particle accelerates uniformly from 2 meters per second to 8 meters per second in 2 seconds, find the values of F. Okay, right. So this means we're going to have to use some of our stuff we looked at last week. So we say it starts at U equals 2 meters per second and V equals 8 meters per second. Okay, so it says if the particle accelerates, so this time is in 2 seconds, and we know that the mass equals 3 kilograms. Okay, so for our question A, what we need to do here is we need to bring back one of our equations of motion. So the one we want to find A, so we can say it's V equals U plus AT. Okay, so that's straightforward. So we have V, which is 8 equals 2 plus A, which we don't know, times by 2 again. And all we need to do is then calculate our A. So we say that A equals 3. But our question asks for what our F is here. So we can say F equals M times by A. F equals 3 times by 3, which equals 9 newtons. So that would be our answer, 9 newtons. So the next part of the question IAA, so CII, says if F equals 6, find the displacement of the particle 4 seconds after starting. Find the displacement of the particle 4 seconds after starting from rest. So we know that U equals 0 now, so it started from rest, and its T equals 4 seconds. We actually want S this time, and we're not bothered about V. So at some point, we're actually going to have to work out what our acceleration is. So we know F equals ma, because we're going to need A here maybe. So we can say 6 equals our mass, which we said our previous mass, what was it? 3 times by A. Therefore, A equals 2 meters per second squared. Okay, so we actually have an answer of 2 here. So now we have U, we have T, we have S, we have A, and we can use that equation S equals UT plus a half AT squared. One of our equations of motions. If you weren't here last week, you will have to look back in the notes or watch last week's videos. So we can see S equals U, which is 0 times T plus a half, multiplied by 2 times by 4 squared, and we find that S equals 4 squared 16 times 2 divided by 8. Well, it's just the same as that, so the answer would be 16, and the rule of travel 16 meters. Okay, so quite straightforward, our Newton 2, and it actually seems quite complicated. But now we're going to maybe combine a few of these. We're going to look at Newton 3, and this is one of my favorite laws. If you want to read one of my recent papers, we investigate Newton 3. So we'll move on